This one thing is going to change the back end of broadcasting as we know it. For many years, broadcasting has traditionally been filled with technical equipment that performed a very specific task. Whether that task was to play audio, or control a transmitter, or convert sound into electrical signals, like a microphone. I have so many things on the shelves here that have become obsolete and have become prohibitively expensive to maintain, to install, to just operate. Take the reel-to-reel machine, for example. That used to be the way to record and play back audio. But with it came so many different maintenance issues. You had to make sure the heads were aligned, the heads were cleaned, that the magnetic tape was available, and the razor blades to edit, and all the different parts that moved had to be lubricated. It was a lot of work, but technology moved on. Computers came onto the scene. At first, it was just for word processing, for logs, for this and that. But then the computers started being able to play back. And then the computers started being able to record more. And then the computers started to be able to do a whole lot more. Today, computers have become so much more reliable, and software has become so much more reliable, that it's what runs media today. Websites, TV, radio, streaming, all of it is obviously computers. And now the next step in computerization is virtualization. Computers today have a lot of computing power in them. And a lot of times your Word document just doesn't take up all that much processing power. So a computer will have so much processing capacity left over. So what do we do with it? So let me take audio processors like this one, like the Optimod and the Omni 11. Let me take those as an example. These are purpose-built computers. They're very specific on the hardware and software. The computer hardware is not overbuilt for the software. It's just enough to give it a little bit of headroom and future-proofing, but it's not as powerful probably as your desktop computer or your laptop or your phone that you're watching this on. Now, a couple of years ago, we built and installed a server cluster and virtualized a couple of machines for our traffic department, which does all the sales and commercial trafficking. Trafficking's a bad word, I know, but basically it's trafficking of commercials and sales. That's the traffic department. We built this virtual server out for them, for their software, through some problems that the software ended up having and the server having some hardware issues. We quickly moved that off onto the company who makes the software onto their cloud servers. So that works out. But we still had these virtual machines. These machines were fine. We just had this problem with the RAID. But we had these things, and they were just sitting there doing nothing. So we have a company that does a lot of IT stuff for us, as well as a friend to the station who has done a lot of stuff for us. I really appreciate him because, okay, we'll get off topic here, but thank you, Luke. I really appreciate you. So we rebuilt this server cluster. We got a new RAID for it, and we turned it on just really recently. That's what I've been working on this last week. It's been great. Spinning up a new machine, putting on the software. We have audio logging software on there. It used to be on a dedicated hardware machine, but now it's just a virtual machine on these servers because these servers have so much capacity of processing power and memory and storage that I'm running 5 machines on it right now, and I'm at like maybe 20% of the server's capacity. So there's a lot of capacity that we have that we're not using. At the same time, I've been starting to see these webinars and these white papers and these discussions about virtualization for broadcast. And what does that mean and how it can... Right now, it's kind of pie in the sky. There's not a lot of people who are doing it. All right, well, that's what kind of kicked me into this little thought process and this exercise that we've been going down this last couple of weeks. So Omnia, which makes our audio processor and makes the audio system that we have, the Axia audio system that we are using here at the studios, they have a software product that is able to be virtualized. It's called the Omnia Enterprise 9S. I know, kind of a mouthful, but this software is the software that runs inside their Omnia 9 audio processor. Their hardware audio processor, it's the same software, and it's running virtually on my server. Why would I want to do that, Marcos? Well, let me tell you why. Because I can run multiple instances off the same hardware. This hardware has a failover server. So if this top machine has a problem, it's going to fail over to the second machine pretty invisibly. And there might be a couple of seconds of downtime, but I don't have that right now. I don't have two audio processors sitting there in parallel at all my sites. This is one way to accomplish that. I could also send that same processed audio over to my streams. And so my on-air and my streams have the similar sound. Not the same, because there's processing that's done for FM that's not sounding good on your streams, and that's a whole nother discussion. But the general sound and the texture and the style of it is now on both outputs. Now, the third thing, and this is where we start getting into this weird new world of IP, is that this software can compress. It's the composite signal, and that's basically a ready for RF signal for radio. So it basically combines the audio, the RDS, all the different parts of the radio signal into a single stream. And it takes that stream and compresses it into IP. I can send that across my microwave link, across my MPLS link, through any other internet connections, cell connections, to a box that will be sitting on the transmitter side. That's the decoder for this. And now this Axia micro MPX decoder will take that composite signal out, and I put it right into my transmitter. Now, my site at San Clemente, my site at Santiago, my site at Prado, all get the same audio processing. This is incredible. This is amazing to be able to do that. And everything is kept here where it's safe. Safe from rats, safe from dust, safe from spiders, safe from intruding fingers that we can't really keep an eye on at different sites. Now, I'm not abandoning my traditional STL paths. No, those still have an important place in the broadcast chain. There are going to be backups in case something happens. So back to virtualization. Now, moving outside of the audio processing world, let's talk about the automation playout. Our current automation system, Wide Orbit, is basically computer-based. Every playout is a hardware computer dedicated to playing out that station. Now, the new system is on that virtual world. It's a server that plays out. It's only a short time until that is virtualized and able to run on hardware just like my audio processors. So let's think about this a little bit farther out. Can you take these Omnia 9 processors, take your wide orbit automation, and run it on something like Amazon Web Services, Microsoft Azure, Google Cloud, your own private cloud system? Sure, why not? There's no reason why you can't. So this will be an interesting precipice that we have on the back end of broadcasting. Now, it does require very strong IT skills, which I don't have that strong of IT skills, but I'm learning. I'm still learning. I will never stop learning. And there are still things like the Nielsen watermarking for audience measurement and emergency alert system. Those things at the moment aren't virtualized, but there's no technical reason why they can't. There's a legal reason why the EAS one can't, but there's no technical reason why it can't. So we're at a very interesting time where you're going to move away from this traditional facility and just have content creation facilities and your backbone infrastructure in the cloud. There's always going to be that place for content creation. You need microphones, you need studio space, you need lights, cameras, all this stuff. It still needs to have a place to be created. But all that equipment that's been sitting in the closet for years, does it need to still take up space in your closet? Valuable real estate in places where real estate is really expensive? It is so different than where we've been in the past for broadcasting. Being able to log in remotely to manage and fix and all this stuff is huge time saver for me. Instead of having to come in here to the studio, I can log in remotely from my phone, from my laptop, from home, from the mountain, from wherever I am, and be able to do most things that need to get done here at the station. So like I said, this has been my project for the last week and a half or two, so it's fresh on my mind. Now we can go a lot farther into this subject, and I want to get farther into this subject, and I'm hoping to be able to get on some of the folks from maybe Telos to talk about virtualization and the broadcast, maybe bring on some IT people to talk about virtualization, kind of more of in a general sense. But yeah, this is a very interesting topic that is growing, and if we can jump on this bandwagon earlier, I think this might be easier to learn and get up to speed. Thank you for being here, for watching this video. While you're here, look at some of the other videos. I did recently talk about the secret sound of radio and what that is. So go check that out. It's right, I don't know yet. I think it might be here. Maybe it's here. You'll see it pop up here in the corner. It's one of these two corners, and it'll pop up here. The secret sound of radio. So I really appreciate you taking the time to be here as we take a peek behind the curtain of broadcasting and media. Thanks again, and I'll see you next time.